lesson 4-6, modeling direct variation. You should be on page 253. Two variables, x and y, show direct variation provided y equals ax and a is not equal 0. That sounds kind of complicated, but it's actually a very simple concept. I want you to compare this to slope-intercept form. So slope-intercept form is y equals mx plus b. Now you notice these two look almost similar to each other. All right. A is the equivalent of m, but you notice there's nothing here for b. Here's what that means. Do you notice b must be 0? So direct variation is an equation that's basically in slope-intercept form, but b has to be 0. The non-zero number in front of x, which they label as a, that would be the equivalent of slope, is called the constant of variation, and y is said to vary directly with x. Let me give you a real-life situation that would directly vary. Okay, pretend it's summertime, and I see you walking down the street, and I ask you, would you mow my lawn for me? I'm going to go on vacation, and I will pay you $20 each time you mow my lawn. And I give you these directions. You mow my lawn as many times as you need to keep my yard looking nice. So you run home and you're excited, hey, I'm going to get paid for mowing lawns $20 a piece. So let me make a little table of that. X is the number of times you mow my lawn. Y is how much you get paid. So I'll put number of lawn mowings and how much you get paid. Well, if for some reason my grass doesn't grow, you're not going to mow, which means you get nothing. If you mow once, you get 20 bucks. If you mow twice, you get 40, and if you mow 3 times, you get 60. Here's what they mean by y varies directly with x. Do you notice? If you double one, you double the pay. Can you see that? If you triple one, you triple the pay. Let's do 4 lawn mowings. You get to mow my lawn 4 times. You get paid $80. Do you see? If you quadruple one, you would quadruple your pay. Can you see how y is varying directly with x? If x is twice as big, y is twice as big. That's what it means to directly vary. This equation, y equals 5x, is an example of direct variation. Do you notice that the b value, there's nothing added on. B would equal 0 for this equation right now. B equals 0, and the constant of variation would be 5 right now. The equation y equals x plus 5 is not an example of direct variation. Here's the reason. I'll circle it in red. I have a plus 5. Directly vary means that b has to equal 0. I don't have b equaling 0. I have a 5 there. This is not directly varying. One of the things they're going to ask you to do in the bookwork is to determine if an equation directly varies or not. If it does, they would have you identify the constant of variation. This is what you need to do to determine if an equation directly varies. To know the answer, you got to put the equation in slope-intercept form first. You got to find out, is this equation, can I write it in that form? If I can, it's directly varying. So let's try a few of those examples. Let's go down here. I want to know, are these equations directly varying? Well, I got to solve for y. So let's do the first one here. Here we are again. We got to solve for y correctly. If you cannot solve for y correctly, it's going to be a headache from now to the end of the year. So onion y, I have to add x to each side. So I have y on the left, and I would have, I'm going to put x plus 1 on the right. Do you see this is not directly varying because I don't have b equaling 0. I have it equaling 1. So this is not directly varying. I'll just put not, okay? Not directly varying. Let's go to 2. I have to solve for y. Let's see if this directly varies. I'll write my work over here. I have to onion the 2x, so I'll take away the 2x from each side. I have y on the left. 0 minus 2x is negative 2x. Now this does directly vary. I'll just put, yes it does, because b equals 0. There is no, the y-intercept is 0, and my constant of variation right now would be the negative 2. There's my constant of variation in this question. Let's try number 3. Let's see if 3 is directly varying. 4x minus 5y equals 0. I have to onion my y, so I'm going to take away the 4x from each side first. So I get negative 5y equals negative 4x, and I'll divide by negative 5, and I'm getting y equals negative 4 over negative 5 is positive 4/5 x. This is definitely directly varying. Maybe I'll just use a highlighter instead. I'll put a check mark. Yes, it is, because can you see how b, it's 0. There's nothing here. b is 0. This is directly varying. The constant of variation I will color right here. It's 4/5. So I have a constant of variation of 4/5 here. I had a constant of variation of negative 2 here. My first problem did not directly vary. Now when you graph direct variation problems, I have already talked about this. Did you notice that this equation is in the same form as slope-intercept form, where M and A are the same thing. M is the equivalent of A, and B has to equal 0, like I've already told you. The graph of this equation is a line with a slope of whatever A is and a y-intercept of 0. Remember, B equals 0, so the y-intercept has to be 0. So it's a line that passes through the origin. So I'm going to circle this. If you look at a graph and you see a line passing through the origin, that's automatically a directly varying graph. So that should be an easy thing. I could make a multiple choice test question like that easy. Have 4 graphs pictured. The graph that passes through the origin is the directly varying graph because the b value would equal 0. So let's practice graphing a few direct, or at least one directly varying problem. Let's try down here. They want me to graph the equation y equals 2x. Y equals 2. So I have my graph paper. My y-intercept is 0 because b is 0. And my slope right now, let me highlight it. My slope is 2, which means go up 2 over 1. I don't need a calculator to do this. Up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Take your ruler, let's draw a line through that. Again, we want to be neat and we want to put arrows at the end, so I'm trying to be neat and I'm trying to put arrows at the end here. That looks pretty good. There is a picture of that graph. Can you see right here that this graph is definitely directly varying? It passes through the origin. You will also see questions like this in the homework. The graph of a direct variation equation passes through the point 4, 6. Let's start here for a minute. When you're reading these directions, when you read that we have a direct variation equation, this automatically tells you that the equation has to look like that. We want to write the direct variation equation and find the value of y when x is 24. Okay, so doesn't 4, 6 mean x is 4, y is 6? I ought to be able to plug a 4 in for x and a 6 in for y, and I can find the constant of variation now. So let's divide by 4 to get a by itself. A must equal 1.5. So I'm going to highlight that. A is my constant of variation. So my equation, it says write a direct variation equation. Here's the answer to that. It must be y equals 1.5x. There's my equation based on A was 1 1/2. And now here's the part B to the problem. Now I want to use this equation and find the value of y when x is 24. Well, that's easy. Take 24 and plug it in for x. So take 24, plug it in here. So 1 1/2 times 24, if I'm doing that in my head right, that should be 36. So when x is 24, y would be a 36. When you have direct variation equations, the graphs will have two major properties that we have to remember. Here's the first one. We've already talked about this. The graph has to pass through the origin. You notice in these examples the graph is passing through the origin. The slope of the graph will equal whatever A is. You will have multi-step or word problems to solve in this lesson. But the key thing, when you read these questions, focus on the vocabulary. This is why the vocabulary is so important. You notice how it says, write a direct variation equation. As soon as you read these words, the first thing that has to pop up in your head is this. B automatically has to equal 0 because the equation is directly varying. So once you have this, then it's easy to plug in your numbers. You can see that they did that. Instead of y and x, they're just using w and s. So you notice how this is the same look as that? So 100 tablespoons of sea salt in a 20-gallon tank. They put 20 in for w because that's the gallons, and they put 100 in for s because that's the salt, and they can find the constant of variation was 5. So there's their equation, S equals 5W, and then you can use that to solve your problem. Last thing, and I'm going to quit the video here, direct variation equations always have a consistent ratio, which I talked about in my lawn mowing example. You know, if you double the amount of lawns double the amount of times you mow, you're going to get double pay. If you triple the amount of times you mow, you get triple pay. You can use this fact to solve problems on page 257, like 29 to 37. So we're going to do one just to make sure you have a sample. We'll do 29. Let's read the directions. So go to page 257, look at these problems. Given that y varies directly with x. Now when you read those terms, let me go back a few pages. Y varies directly with x. I'm going to go back to my first slide. Do you see right here, y varies directly with x? Whenever you read that, that means the problem directly varies, and if the problem directly varies, it's that equation. So let me go back to where we were at on the other slide now. Got to forward here. So back to problem 29, y is varying directly with x, so in 29 that means this equation is the one to use. It says use the specified values to write a direct variation equation that relates x and y. Well, they tell me in 29 x is a 3, so plug in a 3 for x. And they tell me y is a 9, so plug in 9 for y. Well, let's find out what the constant of variation is. Divide by 3, a is 3. So let me highlight that. The constant of variation in this problem is a 3. So here's the equation then. It would have to be y equals 3x. That would be the equation for problem number 29. I'm going to stop the video there. If you have questions, you can ask in class.